On one side we have water. What is H equal to 1.8. Temperature of water is 40 degrees Celsius. Now I think you take help of this. Height of the is 1.8 meter is there, and let the whole water, whole ice, let it freeze. So is it this temperature of water sufficient for the whole ice to freeze? There's a one primary question. So for that we have, so what is the mass of ice? What is the mass of ice present here? We have to calculate. So let A be the area of cross section. Sir, area of cross section not given. Look at that, also not available. But that A will get cancelled out either way. So what is the mass of water? You calculate here, because you know H. This H is there. Initial mass of the water, let it be M1. Initial mass of the is M2. Then M1 should be equal to density of water into area into H. Specific heat of water 1, 40 minus 0. I think I'll proceed in this way. This will be M1S. There's only cross check. I'll do that cross check. M1 specific heat of water 40 minus 0 equal to M2 specific heat of ice. Oh, sorry, this should be LF. M1 should be density of water. AH, this will be 1, 40. M2 should be equal to density of ice, AH into 80. Okay, I think it's not equal, no? You can see this. What all heat that is available here is not equal to. I'm just using some simple basics here. What is the density of water? 1000. Density of this is 800. You check it now. Definitely this 1000 is in fact less than this value. So therefore all ice will not melt. Okay, now we are in better position. Then only some part of ice will melt. So how to calculate what is the part of ice that will melt? So we'll take help of this. M1 specific heat of water 40 minus 0 equal to some amount of ice that melted, M into LF. This will become density of water AH specific heat of water into 40 mass of ice that melted. Shall we? Okay, we'll do one thing. Some mass. This also we can write it as density of ice, area, some x length of ice melted. Anybody value of x? One meter, huh? Yeah, okay, 1 meter. 1.8 meter was the height of the ice column, of which 1 meter will melt. Then how much length of water column it will make it? I think the densities are different here. What length? Because the area of cross section is same, no? So therefore here I'll go for density of ice, A into X should be equal to density of water, A into Y. What length of water column it will produce? When X length of ice column, so this is the length of ice column melts. What is Y? The length of water column that is produced. This one. So the density of ice, this will be 800. X is 1000. This is Y. So Y is equal to 0.8 meter. What I should call? Length of water column produce due to melting of ice. Okay, already we are continued. What to do there? Now we do that 1 meter of ice melts, then what do we get? 0.8 meter of the water column will get hit here. Calculate the height of water in container B. This what the final thing is what being asked. What to do with this after this? Level of water is asking, no? So how much of water will go on this side, how much of water will stay here, we don't know that. Am I right? Some y length of water is formed here. Will it stay here only? No, some part of water will go there, and this level of water will rise. So finally what do we get? We get a situation of like this. How to proceed after this? So this ice is, some ice got melted. Some water will be present here. And what is the temperature of water now? 0 degrees Celsius. The level of water, it will rise. Already it was having h height, so some level of water will rise it here. Now what is volume of water will be? Earlier it was like volume of water will be HA, will be, now it will be HA plus YA. This will be 0, this value we know it. I'll write it. What shall I write here? Volume of water is H plus Y. That L should be equal to Y. No. This Y length of water column, in that sum L1 I'll write it, sorry, L1 water, ice, water, 0 degrees Celsius, 0 degrees Celsius. Okay, I'm able to write this much here. Now come for this one. The pressure at this point should be equal to pressure at this point, or we'll write some other thing, C and D. A, B already we have chosen, no? 1 and 2. Because they are in equilibrium, so pressure at 1 should be equal to pressure at 2. What is the pressure at 1? Density of ice. Density of ice G into 0.8 plus density of water G into L1, density of water G into H plus L2. What is L1 plus L2? Should be equal to Y, no? Two equations I'll get it. Solving this I'll get L1 plus L2 one value. Here L1 plus L2 should be equal to Y. Or AL1 plus AL2 should be equal to AY. It is. Solving this we'll get expression for L1 and L2. Then I can H plus L2 is what our answer. Somebody should work out here. Okay, now you see the calorimetry applications, mixed ideas. All these are some time needed, some 5-6 minutes I think needed, not even 3 minutes, not possible, because reading only question only 1.5 minutes it will take it. Again, drawing diagram, analyzing. So mostly in passages they may break up, they'll ask you. I have answer, we'll take the next questions because 12:30 it is. H plus L2 is cross verify afterwards.